Welcome everyone. I'm Khushbu, Senior Data Engineer working in Atlassian, and I have my colleague Manu with me.
Hello.
And today we'll be talking about how we are leveraging microservices to process data in real-time fashion in data engineering. We belong to Atlassian. How many of you know Atlassian already? Good, all of you. Because when I joined Atlassian a few years ago, I just know Atlassian company by name Jira and Confluence. Later on, I realized that there is a company called Atlassian. Okay, so these are the couple of products which Atlassian owns. We have listed down a few of them here, and Confluence and Jira being the flagship product of ours. But we do have a lot of other products which actually helps in better team planning, collaboration, and management. Now, what is Atlassian mission? In Atlassian, we make sure that we support every single team to do their project planning, management, and collaboration better, because we understand that behind every great human achievement, there is a great team involved. So how can Atlassian make entire team experience better so that the team feel connected, even if the team are working in the remote fashions? With our software and tools, they should feel more connected, efficient, and effective. This is our agenda. We are talking about what problem statement in engineering we are talking about, the challenges which we were facing, and the solutions, and deep diving on the architecture of it, features, observability, and finally, this architecture, how it helped us to win a couple of things within Atlassian. Now, let's start with the engineering problem. So Atlassian started almost 20 years ago with just one single product called Jira. And over the period of time, we have acquired a lot of products from the market, as well as we have developed our own products as well. So if I talk about the acquisition of the products, we have few in the there are a lot many in the list, but I would like to call out few: Trello, Bitbucket, OpsGenie. And just few months ago, we have acquired a video messaging company called Loom. So every other company has their own business process. They can't fit into the same architecture of Atlassian, right? And within Atlassian itself, for the commerce billing system, we started with our monolithic architecture, where every single thing was happening within one service. Later on, we realized that was not scalable, so the team has decided to go via micro-based architecture billing system. So if you see here, all the different billing systems have different architecture, and these are the commerce different entity gets created. So if I talk about this entities, how it actually gets created, so consider an example. Let's say if some person coming to Atlassian website and they start surfing about something, so their personal information gets created. And let's say if they decide to purchase something, they create their account information get created. And then they search for particular products, offerings, and those details. So those details we already have in the backend. And once they decide to purchase some products, their entitlement gets generated, and finally their subscription, the monthly plan or weekly or yearly, whatever the plan they subscribe for it. And once they make a payment, their orders and invoices get generated. Now, if I talk about our internal billing system 1, we don't have a separate concept of entitlement and subscription. It's all one single entity. There's no separate orders and invoice. It's all single entity. If I talk about the Trello product, again, there's no concept of Trello entitlement or subscription. It's called membership, right? But these are the entities which we are following on in the new billing system, that's internal billing system 3. So what happens, we have a lot of front-end applications which are like external consumer facing as well as internal consuming facing. So with this, what happens is now every other portal application has to go and figure out what entity we have to read and where and all we can get the data. And the data was like quite diverse. And moreover, the challenge of this was not every other billing system was generating data in the real-time fashion. It was somewhere giving in the real-time fashion, somewhere was giving in the batch time system. So with this overall design, we were facing a lot of challenges, right? So non-uniformity, as I already talked about, that the data is all scattered because we have acquired a lot of products over the period of time, and they follow their own architecture. The data was quite non-uniformed, and it becomes a headache of front-end applications to figure out what to get from where and how to massage it. Now, it is scattered, source dependent. Now, let's say if the Loom we recently acquired, and if they want to do some business function change, now all the front-end applications or all the consuming applications which are listening to the Loom data, they have to make changes in their source code. So the problem is every other front-end applications was performing a basically redundant code or the transformation. Now the challenges out of this was basically the challenges to the consumer, which consumers can feel it. The latency was quite high because the front-end applications were doing all the heavy lifting of it. The response time of the web screens were not that great. And as I mentioned, that couple of the data was not available in real-time fashion. So let's say if the consumer was raising some tickets, and our customer executives, they did not have all the data in real time available. So our ticket resolution time was quite high. Yep. Now what did we do to resolve all these challenges? So to resolve all these challenges, this was our old architecture. Now we have introduced here single source of truth. So data engineering team realized that if we can pitch in here and build a real-time transactional database, it can help entire Atlassian space. So we have built single source of truth based out of microservice architecture that builds our transactional data system. And as well as once we transform the data, those transformed information can be further utilized by all our analytical system as well. So now all the front-end applications, they don't have to go and hunt around the different data sources because one was in Postgres, one was in Mongo, one was in Databricks. Now they have one single place to look after the data. As part of this process, we made sure that all the source systems are generating data in the real-time fashion as well, so that we don't give the batch data or delayed data to our front-end application, and we enhance our consumer experience. Now, it was more on a high-level solution what we did. Now, let's deep dive into the architecture of it, what we did and what architecture we have built, what are the features of that. And for that, I'll hand over to Manu.
Okay. So let's deep dive into the SSOT architecture. So Atlassian engineering is mainly on top of AWS cloud. So all the technologies we are using here, like related to AWS, like Kinesis, SQS, EC2 cluster, EC2 for compute, etc. So as Khushbu talked about, we have multiple billing systems pushing the data to our streaming Kinesis. On top of Kinesis, internally Atlassian has built a wrapper service called StreamHub, and StreamHub takes care of schema registry, and it is like the internal event bus for us. So to process the SSOT data, we pull this Kinesis data into SQS, and we are following the 3-layered architecture to maintain the accuracy and consistency in the data. When we talk about these 3 layers has the specific functions to perform. The process layer takes care of lending the raw data to our DynamoDB across the events, and here we do add some sort of metadata in our data before writing to the DynamoDB. Once that data is processed, we move the message to the business layer. In the business layer is the place where we perform, we create our SSOTs, We apply all kind of transformations, lookups, etc., to create the final data set for our consumers. And once that data set is created, we move it to publish layer. And the sole purpose of publish layer to write the data sets to the target systems. The target systems like ElasticSearch, we have for the operational use cases to enable the efficient search. And we have the abstraction of GraphQL for our consumers so that they can query this data easily. Now, again, after applying all kind of transformation, we push the data again to StreamHub or Kinesis, and that data gets landed to our data lake. And in data lake, we apply all kind of analytics use cases, etc. Yeah. So how to build these microservices? So Atlassian has built micros as platform as a service. Any of the microservice can be spinned up within few minutes, and we are supporting a lot of languages and working to add more. The microservice setup comes with a lot of features like expected cost prediction based on the resources requested, and a matrix collection process, default SignalFX dashboard, and a Splunk integration, and many more things. How these microservices works, like in our system, when for each microservice, there is a service definition file, and here we define all the resources required for the microservices and all the environment variable, etc. Along with that, if you look at the compose part, we have the sidecar option, the platform statsd. This sidecar is like an auxiliary service attached with your microservice, and the purpose of this service is to send the metrics and to enable the observability on our microservices. So and on top of that, like we all write the codes to do all kind of transformation in our business layer.
In this, we do have a different, for each workers, we have a minimum and maximum instances. Would you like to talk about
For the scalability purpose, yeah.
So let's say if we start with the based on our service initial thing, we start with the minimum nodes. And then when the peak load comes, it automatically scales the service to the maximum node, whatever we have defined, and it's highly configurable. We can go and modify anytime based if we see there is a huge load is influxing. Yep.
Okay, let's talk about a few features. One is cross-stitching. Like, we get the data from multiple streams, with the data which can be logically grouped. So there we are using cross-stitching for those events. So take an example. I got the event, entitlement event, it contains some data. Then I got the subscription event, it contains some data. And my final outcome would look like the combination of both, along with some lookups which we fetch from other services DynamoDB. So this is the overall view of my DynamoDB where I store the events, raw events for raw events, and then perform the cross-stitching to generate the final SOT data. Cool. Then let's talk about the consistency. Since SQS and Kinesis does not guarantee any kind of order, so at Atlassian, we do maintain the sequence, which is in the form of epoch timestamp, right? So all the source systems maintains this versioning to make the consumer's life easy. For instance, there are 2 parallel events for the same entitlement, and let's say I process the latest event first, and the older event arrived late, so I just discard based on the source sequence of the record. So, and while creating the final data set, we do recalculate everything from the raw data sets, the entitlement raw and the subscription raw, which we have seen the previous slide, to maintain the consistency in the data. Prioritization. So every company has the contact information, right? And the contact information comes from various sources. So we have a requirement where we wanted to store the contact SSOT data in our system, but we want it to be more reliable. And the sources of the data are like the first party and to third party sources, right? So based on the business requirements, we have set up the rule engine where we can define for each and every attribute, we can define the primary source of the data, secondary, and an n number of level we can define the priority. So whichever the source, the data is available, that will be prioritized. Otherwise, like you can go to the secondary source if that data is not available. Then we have implemented a change detector. So when event arrives into our system and we are making a final data set, there is a probability that when after applying all the transformation that there is no change in data. So that is something we do after applying all sort of transformation, compare the data which is already written. If nothing has been changed, we don't write it again to the systems. So that way, we are saving a lot of cost in our system. Large payload handling is the another feature which we have recently implemented. So, like the underlying technologies we are using, like SQS, Kinesis, DynamoDB, all have their maximum size limit, right? But 99% cases has been sold with all these technologies, but as Atlassian is scaling, we have the larger customers. So for that, sometimes the data size becomes huge. So in those cases, we have implemented the large payload handling, and it works on the concept like if I have identified a particular payload is large, then I do write the same that payload onto S3 and provide that reference of that S3 file along with the access keys as part of the event. And the similar function we do have while writing to SQS and DynamoDB. On the same fashion, it works. So like we have implemented it to up to 10 MB at this moment, but I understand that that is anti-pattern when I was reading the documents of streaming. But it is like for solving around 0.5% cases. Overall, the designs were working fine.
We have seen a scenario in Atlassian where like the invoice was quite huge, and we realized that that our records were getting truncated because it was not supporting, the existing solution was not supporting more than 256 KB worth of information. So that's where we realized that we have to find out some other solution for that. And we started writing data into S3 and just put a reference here. So, and there is a flag enabled beneath. So once we identify that that's a big payload, what we do usually is we write data into S3, and if we, in the next phase, if we find the data is written into S3, we go and read data from S3, perform all sort of a processing, and then again write back into S3 if it's beyond 256 KB, because internally we are using SQS, and SQS has the max limit of 256 KB.
Yes, and the data engineering team has written the orchestrator for our microservices, and with that orchestrator, the person who is the developers who are building the microservices, they don't need to worry about all these things. So it is handled inherently for those developers. Now, or like every system, like there are failures. So when any failure happen in our data, even after 2 retries, we land them that data into the DL queues. Now, what happened? It makes the life of our on-call engineers tough. Then what we thought of, like, and most of the times what happened after some times, if you replay those DL queues, those issues get resolved. So what we did, using the pollinator, we have set up the process for auto replay DL queues. On a particular cadence, this auto replay service runs and clean up those DL queues. Even if after 2 times or replay of the DL queue, we maintain that counter. If it does not work, then we require a manual intervention, and we inform on-call support engineer to look into those issues. So that's where it helps making the on-call engineers'
Just to
life
add,
easy.
Many of you probably not using SQS. So SQS gives us the main queue and the DL queue. So all the regular records goes into SQS, and if there is a failure, it goes into DL queue. So whenever there was an exception happening, it was going to DL queue, and most of the time it was like, as Manu mentioned, that we were doing cross-stitching of information, right? So sometimes we had to make sure that relevant events have arrived, or let's say if some particular fields are missing on the relevant events. So we make our records to be failed, and after some time, when that relevant information comes in, if we replay our events, it automatically gets successful. So earlier somebody has to do babysitting of this and make sure that they go in a certain interval and then actually run DL queue so that it goes into main queue and then things gets resolved. With this approach, now we don't have to do, and hardly engineers are spending probably 30 minutes or 20 minutes in a day to figure out if there is an exception happening. Otherwise, full day we have to go and sit, and every time there was a record, we have to manually go and put the from DL queue to main queue.
Okay. So ensuring data quality is important for us. So we have many kind of data quality validations. One is at the code level. While writing the process, business, or publish layer, we do maintain those data quality things. Along with that, when we have the schema registry, there we do have the data type validation, not null validation, and some kind of format validation also we can do. But even after that, when the data gets landed to our data lake, there we do the reconciliation, because the source system is also publishing the source systems are also publishing their data to our data lake, and we are also publishing the transform data to the data lake. So on a daily cadence, we do the reconciliation between the source systems and the transform data. Not everything gets validated here, but like most of the things we can validate where we are not applying any kind of transformation, etc., and the count validation. So these are the data quality things which we are applying in our system. Along with that, for the database layer, we started utilizing a new tool called Anomalo for the data quality validations. And then the refresh events. So what happens is, like, today we have applied one transformation in our system, and tomorrow business comes to us and say that this transformation is not correct, you need to change the logic. So now what I need to do, after applying this change logic, since I store raw data already, so to correct all the historical information or to correct certain events, so we have developed the refresh APIs where we can just pass the ID, the primary key of the data set in the business layer, and all the business transformation gets calculated, and the transformation gets fixed, and you can publish it to the target systems.
Basically here, as Manu has already mentioned, we have a process, business, and publish layer. So process layer has all the raw information available to us. So let's say if I have 100 entitlements in my system total, and the business transformation got changed. So I don't have to go to source system, please publish me the data once again, or whether you have data or not, or did you lost it. We don't have to go and check all those. We have all our raw data available in the process layer, and we just run our business layer. And while running the business layer, what it does is it performs a lookup on the raw layers, raw event, and it again do transformation and give the fresh data to us. So that way our layering architecture helps us in during any business transformation. It helps us to do refresh, and this is quite a good feature, because we realized, as Manu mentioned, another example which he gave, the contact information. Let's say we decided if any persons are coming in Atlassian, and if we are getting that person information from the Atlassian, we should consider that as a, let's say, level 1 information, gold information. If it comes from the third party, it's considered as a level 2. And let's say if it's manually somebody is feeding, it's considered as level 3. Down the line, for just a vague example, if somebody decided, okay, no, let's put the third party as the primary and the first, the Atlassian, whatever it's coming, consider as a first, second. So we don't have to go to again source system and do a lot of things. What we can do is in our rule engine, we can just change the priority and refresh based on the primary key. It will go and check from our, pick the records from our process layer, and it will give us the modified data and write finally back into our target system, which is Elasticsearch and the data lake.
Yep. Khushbu, now Khushbu will talk about observability.
Any system, if we don't have observability, it is like half completed, or we can't call, there's no trust on it, right? So, okay. In Atlassian, as we already talked about that micros as a service, we have a platform as a service, basically the microservice. So that comes with a lot of packages. So there we have a Compass, which is again an Atlassian internal inbuilt tool, which helps you to give a complete health check of your microservices. Here if you see, it will tell you how many deployments per week it happened, how many PRs have been raised, how does your system microservice health look like, and it talks about your who and all are your owners, and if you have on-call roster, it gives you information about that. And we do have, let's say if we have a run book information, cost information, if we created a lot of documents about it, we can store all the links about it. So this Compass basically helps all the engineering people within the team to get the sneak peek about their microservices, how it's working. Now comes to monitoring and dashboarding about the logs information. So as Manu talked about that, we had a sidecar implemented, which already captures the detail about each events and all. And once that captures, it sends to the SignalFX. Internally, we are using SignalFX for monitoring and visualizing about the loggings. So here, if you see, we store all the information, like how many events are coming in, different types of events, what are their counts. We store that information. And as we mentioned that we have 3 different layers. So we want to make sure that events are not getting lost in between. Let's say if 100 events came in the process layer, we want to make sure that once it goes out, we have 100 events. If we want to drop certain records, then a different story. But at high level, we want to make sure how much ever events we are getting it, we are finally publishing that many records. So this particular place, it tells us like how many events came in and how many events got successfully processed. We do capture about like what different type of exception have been come and what are their counts. So internally how we have designed was we have created a accepted exception and the exception which is not accepted. So if we find there is a significant increase in not accepted exception, we created a ops genie alert out of it, and if the threshold breaches, the alert goes to go to the on-call person, and his responsibility is to make sure that he goes and figure out what actually has been the issue of it. Apart from this, we have in our service.sd.yaml, we had a feature to add our Slack channels as well. So if there is any exception arises, automatically it goes into Slack channel as well. So if somebody wants to go and have an immediate look of which particular event caused the problem and what was the issue, they can go and check on the Slack channel as well. Now, so this is about all our services, the problem which we had and the solution we built. Now, the wins. So after building this, we had a significant improvement on our commerce data analytics side and as well as on the operational side. So basically with the single source of truth, we gave a data foundation for real-time data within the team. Now front-end application don't have to do the similar job, different, and the analytical team, again the growth team, the sales team, the commerce team, they were doing almost the same sort of effort everywhere. Now they've got a good solid foundation and everybody's job was simplified. Otherwise, what was happening was the metrics were all different in all different places. And as part of this, we had enabled our real-time analytics insight for our marketplace vendor as well. So earlier marketplace vendors were getting how their products are performing in the Atlassian in, let's say, 1.5 day worth of gap. With this, as we mentioned that we transformed the data, we landed the data into ElasticSearch for transactional operational use cases, but same time we landed into data lake as well. So our analytical pipeline also became started running in fewer cadence. So our marketplace vendor, instead of 1.5 day gap, they started seeing how their products are performing within 2 to 3 hours of gap. So that way, they were quite happy to know and they get a real insights of how their products are performing. Now, enhancing ticket prioritization, when customer support executive, when they get a ticket, they want to get a lot of information about the consumer and the company who raised that ticket and serve them accordingly. Earlier, because everything was batch, with making everything as a real time, now they were able to resolve a lot of tickets on time and we had a happy customer faces. So with all this wins, I conclude here and we open up for Q&A.
Hey guys, quick question. When the data lands on data lake, how do you guys query it? Meaning, what do you guys use to query it and power your?
So predominantly we are using Databricks for querying and all our reporting dashboarding is being done in Tableau.
Okay, so you guys use something like Spark SQL?
Spark SQL,
okay.
Yes.
Yes.
So any like rendering issues or performance latency kind of issues that you see, like reading from S3?
So once the data gets landed into Databricks, it's all like analytics query. So I mean, whatever the performance usually we see, it's performance-wise, it's the same. I mean, this is to make sure that we are now n number of applications were hunting the data and doing the same job. Now we are making sure that we are giving data in almost near real time to the analytical system as well.
With this, I think with this microservice architecture, you guys solved the data freshness problem.
Yes.
Yep. Now the next step I wanted to understand is like the latency, if there is any issues in the dashboard side in terms of rendering. Now the user is interactively submitting some dashboards or some queries. Are there any?
So with this, as of now, the interactive query, the Tableau dashboard things are, we did not cover that scenario here. This was more to solve the front-end applications problem. So for that, as of now, we are also trying the hot tier solution. We are evaluating Pinot, Druid, and StarRocks. So once that our evaluation is done, most probably we'll land our data there and to solve our analytics real time. Huh.
Yeah, Sandeep just wants to make sure that you're trying Pinot.
Is your so this microservices architecture kind of works for like real-time streams flowing in? Do you use the same solution for like backfilling? Because backfilling the data for like whatever systems that companies that you acquire, they must have like huge amount of data, right? So do you just let the data flow through the same pipelines? How does that catch up?
So yes, it comes through the same pipeline. Internally we have created different queues. So what happens is for the process queue, business queue, and process layer, business layer, and publish layer. So what we do is, let's say if we find, we can create n number of queues which can listen to the process, and let's say this is a process layer which can listen to the multiple queues. So if we feel that if I have 10 sources and every other sources is sending huge data, I can create a number of SQS queues accordingly. And then in the process layer, I can increase my worker size to process those data huge. And then if I feel that there are a lot of redundant data or the data which I don't require and we are discarding a lot of events then and there, I'll tweak my business layer resources accordingly, and then so on in the publish layer. So that way we handle our load.
And for example, there is a large payload handling, and sometimes it takes time to process those large payloads. So we move the data into the process low queues, like the data currently working in the process layer. We don't want to impact the real-time process. So we route that data to another queue so that they can that can run at their own pace little later.
Thanks.
So in this microservice approach that you have, how does the situation failures play around? Meaning that, for instance, have you experienced message loss? Meaning you read one message from Kinesis, in the middle of processing, service fails, coming up. Do you keep track of those messages that you read this or not? Especially as Kinesis doesn't have notion of exactly once. How do you guarantee these type of processing to be done only once?
In my 3 years experience with these microservices, I never faced this particular challenge, but the service went down because it is like highly available. But in case the service went down, the events arrived and lands to our SQS. When the service comes up, they pick the data from the SQS, and that is a separate service, which we talked about, the stream hub, that keeps the data in the Kinesis, and from Kinesis streams we can restart that data.